speaker is Masaaki Ubukata, and I think from Joel, correct? All right, the floor is yours.
Okay, and hello everyone. Thank you for giving me this opportunity. My name is Masaaki Ubukata, coming from JEOL, Japan, Tokyo. So today I will be talking about our unknown compounds analysis method using the high resolution mass spectrometry and the soft analysis technique, and also we are using the AI technology on the software for the GCxGC data. So this is the outline of my talk. So at the beginning, so I would like to explain about the GCMS and the GCGCMS qualitative analysis workflow and issue. Okay, of course, you guys are professional for the chromatography. You guys totally understand this workflow. So at the beginning, so we have to do some kind of the sample prep, and also we are using the pre-treatment system for the GCGCMS, like headspace and sample dissolution, something like that. Then we can introduce a sample into the GCGCMS. Then we can get the many compounds in the GCGCMS data also. And in that case, so data processing is quite important. And right now, so we can use volcano plot, PCA, or something like that, for to extract your specific compounds. And after that, so we can do qualitative analysis using the EI spectral database search, like NIST. But I want to ask you guys, so if your compound, your specific compound is not listed in the NIST database, how to identify these unknown compounds? Of course, you can read the mass spectrum directly, and you can estimate the structure directly from the mass spectrum. But I can say it will take a long time, and it is really difficult. So this began to motivate for the developing for the AI technologies on our software. Okay, so honestly speaking, NIST database is quite nice and quite useful for the GC EI data analysis. And as you can see, latest database contains 350,000 compounds in NIST database search. But more than 100 million compounds in PubChem, so it means that so we are recognizing for this kind of many compounds in the world. So almost all compounds are not listed in the commercially available database. So only 0.3% of all compounds registered in database. So in many cases, they become unknown compounds. And right now, JEOL proposed an automatic structure analysis solution using the latest AI technology for real unknown compounds. Okay, so again, so there are a lot of unknown compounds in the world. So in that case, so at the beginning, so we have to know about the composition formula because we would like to understand the chemical formula from the mass spectrum directly. So in that case, we have to use high resolution mass spectrometry. And right now, so you can see, we can get this kind of very beautiful high resolution separations, and we can estimate the chemical formula, composition formula from the EI mass spectrum. And the next step should be the molecular formula identifications. So as you know, EI is the hardest ionization. Sometimes we cannot see any molecular ion information in EI mass spectrum. However, if we use the soft ionization techniques, so we can clearly see the molecular ion directly. And if you use the high resolution mass spectrometry, we can calculate molecular formula using the time of flight and soft ionization techniques. But honestly speaking, so actually our customer would like to know about the structure formula, not only the molecular formula. So this is the final phase for the real unknown compound analysis. But for the structure formula, we can do by yourself manually from the mass spectrum, or do the software automatically. Which one do you like? So right now, JEOL proposed 3 technologies for these 3 formulas. So composition formula, we can get the composition formula from the high resolution time of flight mass spectrometers. And we can get the molecular formula information from the soft ionization technique like photoionization PI and the field ionization FI. And also right now we are developing the software MS Fine Analysis AI. Then we can propose structure candidates on the software using the AI technologies. So today I will talking about this kind of the AI technologies. Okay, so from here, I would like to explain new qualitative analysis workflow for the unknown compounds. So actually, we have the two parts for the unknown compounds. So first part should be the integrated qualitative analysis. Okay. So this is the integrated qualitative analysis workflow for the unknown compounds and the known compounds. So we have to set two data. One is the GCEI data, and another one is the substantiation data. And the software can analyze automatically. And at the beginning, so we'll do the NIST library data search. And also we can do the molecular ion analysis using the substantiation data. And actually, software can do that automatically for the EI fragment ion analysis. I mean, we can get the composition formula for these EI fragment ions. So it including the substructure information also. And after this workflow, so if your compound is listed in NSD database, it's okay. We can still have a very big confidence from the substantiation data also. But if your compound is not listed in NIST, so we can get the chemical formula, and also we can get the fragment ion formula from these workflow. And after that, so next steps, we can go to the AI technologies and the AI structure analysis. And from here, so I'd like to explain about our AI structure analysis solutions. So right now, we are making the 3 AIs for the structure analysis automatically. So actually, JOL uses a combination of deep learning and machine learning for the unknown compound analysis. So actually, we made this kind of the AI library, means predicted EI mass spectrum database by ourselves. And we use 2 AI models. So one model can predict EI mass spectrum from structures. And another AI model can predict retention index value from structures. Then we combine these information into one library. And another AI, we can predict substructure information from the mass spectrum directly. Okay, so this is showing our AI libraries making workflow, I mean. So actually, we are using the graph convolutional neural network to predict EI mass spectrum from structures, okay? And we prepared 130 million structures. Then we put these structures into our AI model. Then we got predicted EI mass spectrum and retention index value. Then we combine these information into one AI library. And of course, I have to explain about our AI model performance. So this is showing the cosine similarity using the evaluation data. So we are using the 10,000 known compounds for testing, okay? And this is a distribution diagram for the cosine similarity scores. So actually, averaged value was 0.8. Of course, cosine similarity score maximum number is 1. So I think 0.8 is quite high numbers. And this is just an example for this kind of the evaluation data. And the top one, so black color means measured real mass spectrum from NIST database. And the red mass spectrum is predicted mass spectrum using our AI model. And we got this kind of very good cosine similarity score for these structures. Okay? So you can see almost all fragment ions pattern is correctly. And the medium one is almost same number with averaged values. And as you can see, main fragment ions and the pattern is completely same, but slightly different for the minor fragment ions, unfortunately. And the bottom one is very low score for the cosine similarity because it has very unique structures. So in that case, it is a little bit difficult to predict correctly. But again, so we got average score 0.8 for 10,000 known compounds. So we had very big confidence for our AI model. And this is another testing evaluation for our AI models. And actually, we use 10,000 compounds again for this test. And you can see this table. So here is a correct structure for known compounds. And this is top one similarity scores structures. So actually, 41% compounds, I mean the almost 4,000 compounds had same structures with the correct structure in the top one candidates. Okay, and 46% had a similar structure. I mean, so I have to say it is kind of the false positive. However, you can see these structures have a very similar. I mean, just the differences for the position of the functional groups. Okay, so I can say so totally 87 compounds were elucidated, correct, and similar structures. So right now, so we have also very big confidence for our AI model. Okay, for after making our AI model, so we prepared 130 million compound structures, and actually 100 million compounds coming from PubChem, and we made 25 million compounds for the polymer pyrrolysate by ourselves in silico, and also we made 5 million TMS compounds by ourselves for the metabolomics analysis. Then we inputted these compounds into our AI model. Then we got the predicted EI mass spectrum. Then we made the AI library for the database searching. Okay, and this is showing the AI total workflow. And at the beginning, so we have to do integrated qualitative analysis. And if your compound is not listed in NIST, so we will go to the AI library search. Okay, but actually, this mass spectrum, just our AI model predicts this EI mass spectrum. Nobody knows, it's not real. So in that case, so if our unknown compounds, we will go to the AI library directly, maybe we may have wrong structures. So in that case, molecular formula information is quite important because we already get this molecular formula information after the integrated qualitative analysis. Then we can use this molecular formula information as a filter, narrow down the structure candidates, okay? And honestly speaking, so we can narrow down almost 4,000 or 5,000 for the candidates. And after that, we can compare measured EI mass spectrum and these isomers predicted mass spectrum. Then we can get this kind of the structure candidates on the software. So this is the total workflow of the unknown compounds, so integrated analysis and the AI library search also. Then we can get structure analysis result automatically on the software. Okay, so after the all processing, so we would like to recommend to use the software technique and the AI technology for the identification of the unknown compounds. Okay, so from here, so I would like to explain about slightly easy and not so in detail, but I would like to explain about software and the applications. Okay, so we tried petroleum analysis and the metabolomics analysis using our AI model. And also this is showing the kind of the hardwares. And we are using the inside thermal modulator from the Cepsolve. And it is quite nice and it is very easy to use. And this is showing the GCxGC parameters. And we used EI-FI combination ion source for the two measurements. One is GCxGC-EI and another one is GCxGC-FI. Okay, this is just showing the thermal modulator performance. So this thermal modulator is a liquid nitrogen free cryo system and minus 100 degrees Celsius as a chair. And actually, we would like to use normal alkaline retention time to generate measured retention index for GCxGC data. And we tested normal alkaline mixtures on the thermal modulator. And we could trap from C7, even though using a liquid nitrogen free modulator here, it is quite nice and beautiful. And we can use this kind of retention time information for the retention index analysis also. And this is our software graphic user interface. So you can see GCxGC-EI data in here and GCxGC-FI data in here. And also we can see the mass spectrum on the software, of course. and we can get this kind of the structure information from NIC database or our AI library. And this list had all information such as the compound name, CAS number, and the PubChem CID, and also accurate mass analysis result. All information in here in the table. Okay. And again, this is a total workflow, and for the analysis, we have to set GC by GC EI data and the GCGC software data. Then software can generate structure information automatically. So all workflow can be done automatically on the software. Okay, and we will go to this compound analysis on using our softwares. Okay. And this is showing the EI mass spectra here, and this is the FI mass spectrum. So in EI, so we cannot see any molecular ion in here, but in FI, we can clearly understand molecular ion information, and we can calculate molecular formula C14H30. Okay, and these information from the NIST database search, but totally this is wrong answers from NIST. And after the analysis, this component is not listed in NIST, so this is the time to go to the AI library search. And this is also a graphic user interface on the software, and you can see left side, we can see all structure candidate information, okay? And this is measured EI, and this is the predicted EI mass spectrum from these structures. And also this is showing the measured EI mass spectra and the calculated composition formula. And also we can calculate the fragmentation formula automatically. And also we can get substructure prediction by machine learning information in here. So totally you can have all structure information on one window. And also we tried just a metabolite analysis in Japanese sake. So this is just one slide for these applications, but actually this is showing the disaccharides compounds using with the TMS derivatives. So in EI, so we cannot see any ion in here, but we can see the molecular ion MOZ 947 in FI mass spectrum. Then actually this component is not listed in NST, but we got this structure candidate from our AI libraries. Okay. And also this is one of another feature of the software. So actually we will have this kind of the automatic categorization using the measured EM mass spectrum. So of course, similar structure compounds have the very similar EM mass spectrum. So in that case, we can use this kind of the classifications. And of course, this is diesel data, and this is normal alkyne and alkene and aromatic, something like that. So in that case, so sometimes so we can get the correct structures from NIST, but sometimes we cannot see any structures in NIST, but we can totally understand this should be the little bit similar structures, then we can select correct structure on our AI libraries. And this is also the automatic categorization for Japanese sake. And it has many, many colors, but I think it might very helpful to selecting correct structure on our AI library. Okay, so this is the conclusion of my talk. So right now, so JOL proposed 3 technologies for the structure analysis solution for the real unknown compounds. So again, so we made 130 million predicted EM mass spectrum database. But it is very important to combine molecular formula information to obtain the correct structure formula with AI library. Okay, and right now, so we are thinking JOL propose this solution of the real unknown compound analysis for all GCMS data and GCGCMS data. And actually, we have a booth upstairs. So if you have interesting about this technology, so please visit to JL booth so I can show the latest software for you. Okay, so that's all I have today. So thanks so much.